Yeah, my laptop froze there at a bad point. I don't know if it's because we have so many people on the call, but it's great to see everyone here. So we're at like 23 people. I'm pretty sure that's a record for us hosting in GatherTown. I know that limit is technically 25, so we're getting pretty close to that. I don't know what happens if we reach 25, but I guess we might find out. Yeah, I think you were saying, Hitesh, we should probably dive straight in, since there's, I think, 12 presentations today out of 16 projects, which is great. I'm so excited about, like, this is our biggest grants round yet. We just expanded from 5K to 10K. We got like a record number of proposals, and I think like the projects are super high quality as well. So I'm just so excited to see all of these new projects in the community, and that's really what it's all about, is like building a community around these projects where we can all build stuff together, you know, ask each other questions, support each other. And so, yeah, it's an exciting day because the Algovera community is growing. So it's great to see everyone here. Okay, let me check who is up first. It's Pytorch NFT checkpoint with Sharif. So please fire away. 4 minutes plus 1 minute for questions is what we're aiming for.
Awesome. Let me share my screen. Okay. Can you guys see my presentation?
Yeah.
Okay. Yeah, so hi guys, my name is Sharif, and my idea is Pytorch NFT checkpoint. So I think anyone who has ever done some work in machine learning, deep learning, data science, use something like a model zoo. So a model zoo is an open source models that you can find online that you can use. So for example, this one is from Pytorch, this TensorFlow, this is a thing I did a couple of years ago. And the problem is no one really knows who did the training of each model, right? And you are not sure if the information that is written down here is actually correct. So that's the idea behind the Pytorch NFT checkpoint. The Pytorch NFT checkpoint makes sure to actually save who did the training of which model on which data. So how does it work? The main thing of the Pytorch NFT checkpoint is it hashes, so it takes a hash of the model weights and some metadata, and the metadata includes things like the data itself, the time it took to train it, the accuracy of the model, the size of the model, something like an inference time. And you take this hash every n epoch, right? So it could be every epoch or every 5 epochs. And each time you save that hash. And at the end of the training, you look at all your training epochs, and the one which you have the highest accuracy with, you actually mint the NFT, right? And when you mint the NFT, it is safe forever who did the training on which data, and so on and so forth. So the deliverables for this time would be a working Pytorch NFT checkpoint. Yeah, so every epoch you would save the hash, and at the end of the thing you would mint the NFT, and it would have to be very easily installable for the latest Pytorch version, right? About potential next steps, there are a lot of things that could be built on top of it. Something like a dynamic NFT design, which depends on the model that is trained. You could have some kind of tradability. So for example, if you think about, you could actually use the NFT as some sort of API access gateway. So the person that holds the NFT can collect some access fees, right? And this is a revenue that is tradable. It could be used as a classic access gate to some sort of community. And because it's an NFT with the hash, it's very easy to validate who did the training on which data, etc. Right? Other than that, you could have something like the IPFS integration, which is made very easy by the actual hash which is produced, right? You could take that and store the actual network models behind that. Other than that, interesting idea. This could make research citations much easier to verify as well. Yeah, so this is the overall idea behind Pytorch NFT checkpoints. Questions, comments?
Bang on.
Perfect timing.
Yeah, I have a question. So I'll post this. Maybe you can like look into it. It's called proof of learning. Oh shit, that's not it. But it basically is like the issue of one issue. Like I think it's a really cool idea, and I think you should definitely. It's really important. One issue is that I can take that hash, I can add random noise to it, or like let's say 0.0001 to it, not really change the weights, or even quantize some like one weight, and it changes the whole hash. Like I can like let's say take a very small variable and just make a very small change to it. So like I think this is a really good first step. What they try to do to help circumvent this is through proof of learning, which like they'll take a bunch of like a roll up of all these training steps, and then they'll go through each training step and then see if it's consistent, and if it breaks, then the whole proof breaks. So like yeah, so because like, if you just save one part of it, then like you can like I can, let's say you post that as your like, oh, this is my model. I can take that hash, I can then add a small little thing to it, and then change the hash completely. And now I have basically the same model, but it's now it's under a new hash, so I can have a new IP for it. So this isn't really solved. I think this is a really good first step though. I'm not sure if you've looked into the proof of learning, but they basically do that in a way. They save the metadata at each step, and the code is like right there. So I think this is like a really we're trying to do something like this too, but it's really important to save your checkpoints and have that IP. I think it's a really cool idea.
I think that's all we have time for there. If you want the guys to chat, maybe you guys can set up a after, or if we have time after, you guys can chat about it. Feel free to use the space after as well to do it. Should we move on to the next one?
Yeah, so next up is AcuiQ.
Hi guys. Let me know if you can see my screen okay. Can you all see that?
We did for a second, but it's gone.
Okay.
Yeah.
And you can see the slideshow?
Loading. Yes, we can see it.
Okay, perfect. So, hi guys, nice to see you all. AcuiQ, it's a recommendation engine for traditional Chinese medicine. That's the link to the MVP, and thankfully the database has been rebooted. If you can't scan the QR code, then this is what you'll see. The input to the model is a list of symptoms, in this case, headache and a cough. Oh. Slide isn't really okay. And the output of the model is a treatment list of acupuncture points and herbal remedies. And you can see the confidence level of the model is in the top left there, just under the treatment list. The revenue model is press needles. Press needles are 1.5 millimeter acupuncture needles that you can self-apply. They're really safe. They're often prescribed by acupuncturists themselves. Then herbs are more expensive, and then the high ticket items are massage chairs. You can pay in crypto at the moment, Nano and Ethereum, but eventually this is going to be on Radix. The data that we've gathered is firstly 605 acupuncture points. 305 of them are canonical, and the other 300 are sort of more rare and less well known. For training the model, we have at the moment 14,000 case studies. I think in a fairly short time, this could be pushed to 100,000. And then if we can have some kind of scraping algorithm and an efficient way of data inputting, then that could be pushed a lot higher than that. Just to give you an idea of consumer demand, so the original project was AcuiQ.com, which is still up and running. And you can see a continued demand ever since 2019. Actually, this is only up to April this year, but I'm not sure of the recent months, but you can see the trend anyway. So the opportunity, the alternative therapy market is nearly 300 billion by 2027. In London, where I am, there's 175 acupuncture practices just in my area alone. And on average, they're earning 40,000 a week. So the vision is to distill practitioner knowledge of symptoms, protocols, acupoints, and herbs into an authoritative machine learning model of best practice. This is the team, myself, Solly, the developer, Dr. Zhang, and Dr. Hunter, who are just advisors at the moment. So funding would go towards the MVP. User feedback is crucial for the model. We go on data collection, as I already mentioned, and model development. That leads on to the expertise that we need, which is on data formatting and model design. A few frequently asked questions: is this legal? Yes, we're not doing anything that is not already being done. Thousands of websites and magazines already recommend treatments, and pressed needles and herbs are sold on eBay, Amazon, etc. Is treatment safe? Yes, the pressed needles are only 1.5 millimeters long. You can't do much damage with them. And as I said, acupuncturists regularly dispense them for self-treatment. The algorithm that we're currently using is Levenshtein pattern matching. And the machine algorithms that we've tried and haven't worked are LSTM and transformers. So that hopefully is 4 minutes.
Yeah, that's bang on time again. It's great if you guys can all keep like this. It's amazing.
There you go. Awesome. Yeah, I first met Andrew at a DeSci Berlin, and we were chatting about applying data science to this. And correct me if I'm wrong, Andrew, but you're looking for like data scientists to work with as well to help to develop like models like the LSTM and Transformer.
Yeah, at the moment I'm just kind of researching myself, and I coded the initial MVP and messed about with LSTMs, but I need a professional really.
Yeah, hopefully we can help you find some in the community. So if anyone is interested in jumping on board, like just get in touch with Andrew or myself. Cool. All right. So questions. I know we chatted about this for a while on, I think, Monday already.
Yeah, and I covered them in the FAQs, I think, so.
That's a good sign. Great.
Very clear.
Any more questions can be in the chat. And I can also reach out to Andrew if there is any more questions.
Cool. So next up is Yishai and Microclimate-Strain Map.
Hi everyone. So I'm Yishai. I don't know if I should share my screen really because I haven't made a presentation. I only have like the grant proposal that's already on the forum. So what I want to do is create a map of, wait, maybe I should share my screen so I could see it too. So I will be, okay. No, we'll do this like this. Okay. So I want to create a microclimate-to-strain map to help farmers and urban growers and cultivators all over the world to create better matches between available strains and species and cell cultures and their microclimates in their home countries. So while the data on microclimate is readily available, it is not matched to any specific strains or species. on a global level, absolutely not. Sometimes on a very local level. While the data on strains, seeds, species, and suppliers is partially available, but never mapped to the microclimate. So that is something that I want to help solve with this project. When the funding is going mainly for research on available open data sources, open source data, and the rest will go for a data scientist, hopefully from within the community. Ideally, the outcome of this project will be a GitHub repository that is open to everyone to build on top of it, to make it more available to more people and more variation on the project, especially if anyone wants to build further pipelines to upload more data into the framework that we're going to build. And I think this is about it. So if anyone has any questions, I'll be happy to answer.
Awesome. Thank you, Yishai. Yeah, so just for context as well, this came out of a hackathon that we took part in with Links.
Yes.
And I was on Yishai's team, and then really liked the idea, so encouraged them to go for a grant. So I'm really excited about this application. Yeah, does anyone have any questions?
And I should also say, for context, that the original idea was to make it also part of a global supply and demand mechanism to help farmers and suppliers actually contact each other and transfer the packages around across borders. But since here we're focused more on data, then I put aside all the supply and demand parts, and we're going to focus just on open sourcing the data and creating a good framework for people to understand what is the best species or strain to grow in their field, on their rooftop, in their balcony, or wherever else they want to grow.
What's your background, Yishai? Maybe you can tell everyone. I think it's great to have, we have lots of data scientists here, but it's great to have other types of stakeholders, like domain experts.
So actually, I got involved with this whole strain mapping thing because I felt the problem firsthand. Being a mycelium supply business owner, it is quite a hassle to get the right strains across the border from the right countries and match them to the right climate. And I think it's a big bottleneck for all industries that involve cultivation of any kind. On a large scale, there are people who take care of it, and there are companies who specialize in certain climates. But the smaller you go, then you're left to your own device to figure it out. And researching this can be quite a hassle. Yeah.
Awesome, thanks. I heard you describe your background before as you sell mushrooms, so I like that description too.
I never know how deep to go. I do sell mushrooms. I try to focus mostly on selling mycelium for people who want to cultivate themselves. Yeah, the shroom boom only hit Israel in the last year or so. So I'm one of the first to do this in Israel.
Cool. You'll have to send some my way.
Exciting.
You'll have to hook me up. Okay, cool. Yeah.
Come to the desert. We'll do mushrooms in the desert.
Get me in. Okay, sweet. So next up is Eden Protocol. I think we have a few members. I'm not sure who's presenting. Maybe Blue Panda?
Don will do it. He's really, really good at presenting, so you guys will have fun.
Great. No pressure. Thanks for that, brother. Fuck. All right. Anyway, yeah, so yeah, there are a couple of us. I think Milo is there as well. So yeah, Eden Protocol from Developer DAO. Thanks for having us. Thanks for listening to us. So yeah, super quickly, Eden Protocol, the problem that we're trying to solve, or that we are solving, is basically project person matching. So especially if you join a DAO today, for example, you know, there's loads of interesting people. There's a load of potentially super interesting projects, but the connection between the two is actually really, really hard to make efficiently. So that's in the DAO today. That's a challenge that we're solving in a pretty simple way with a bot, where very simply you could, I mean, I guess I could show you right after if there's time, but very simply you could just sign up, you know, show your skills, and you get a couple of projects back that match your skill set. So that's the very first part today. But there's actually an opportunity to do way more than that, and especially when it comes to, you know, the bot and the way that we're building it is, you know, Miltos as a PhD in machine learning and did like graph convolutional neural networks, and wow, that was a big one. At Goldman Sachs, where, for example, like these synergy spottings happened, and so this is something that we can start using to create way better project person matches than we're able to do today. Because also one of our beliefs is that, you know, we believe today we have an opportunity to not only do algorithms do the work. So with Eden Protocol, we're really trying to combine, like on the one side, you know, creating great algorithms like you would, for example, find on Upwork, that do basically like freelance, you know, project matching. But the problem with these matching algorithms today is that they have a very limited data view, if you will. Like, for example, on the when it comes to the freelancer, the only information that you have is like the self-reported skills, types of work that they've done before. And then there's like a kind of like linear view on every single job that they do, and they get a 5-star rating. And based on that, you kind of like start making matches. Now, in a DAO context and in a protocol context, we actually have an opportunity to start combining not only algorithms, but also like, you know, the community view on things. Like, for example, within the bot, we've built an ability to endorse people. And then you can start using, for example, somebody that they themselves endorsed 250 times for machine learning as a stronger signal than, for example, my mom endorsing me for machine learning. And that way you can start creating models, especially if you start thinking about how to create skin in the game mechanics, that can provide, you know, data sets that are a lot more truthful. Like the noise to signal ratio is a lot lower, because you know, if I am staking 50 tokens on the fact that you are a machine learning engineer, and I can lose them if that's not true, that signal is better than, you know, the endorsements that you see on LinkedIn today. So yeah, why does it matter to have better project person matching? Is if we can reduce the time, or like the you know, the time to, for example, do interviews and all these things, like to zero, like we can truly enable completely permissionless work. And so by combining all these different views into this kind of like, using machine learning and AI techniques in a very smart way, like, for example, NLP as well, we can start creating way better project person matches that can enable truly permissionless work. And that's the way that we can, you know, allow DAOs to become a completely new way of working that is a lot more purpose-led. Yeah, if there's any question, I mean, I could show you quickly. I don't know if I have time still, but for example, this is what our Neo4j then looks like for one of the DAOs, where you see all these skills, you see all these people, you see projects, you see roles, and these roles are a collection of people. And so this is like the very first version, but you can then also like start seeing endorsements. Like, for example, here you see that Impact Billy endorsed. Perfect. That's, you know, there's a lot that you can start doing with that graph is basically what you remember. Yeah, cool. That's that. Any questions?
Awesome. Thanks, Tom. Yeah, I'm super excited about this. There's just so much data in Web3 now, and we haven't even started to like analyze and process it. So like what new applications are going to come out from all of this sort of stuff is super exciting. Does anyone have any questions for Tom and Eden Protocol?
Somebody had a hand up. I don't know if that's a hand up by accident or if that's a hand up for a question.
Yeah, that was me. Can you hear me?
Yeah.
Yeah, sure. So is your person project matcher solely based on graphical algorithms, or do you have some sort of something different in the background as well?
So we have, so right now it's a very simple match, right? Like I think like our project is about 2 months old. And so the graph is obviously a huge part of it, but there's different techniques that can be used at different stages. So I guess it depends. Like, can you maybe be a little bit more specific with what you're looking for in your answer, or?
Yeah, I think I have a major part of the answer right there. But what I was asking was mainly, do you have graphical algorithms solely working on your backend, or do you have some other algorithms also working with you?
So Blue, take it, go for it.
Yeah. Okay. So basically, today we are really careful to not use ML, and that's a really important part. That we first have to have a product market fit and see that people truly care about these connections. At the same time, though, we are building a really strong foundation of the graph system using Neo4j, as you saw, a graph representation that exists right now, and we are moving towards graph machine learning. But also, as you are asking, we are moving towards natural language processing. The natural language processing is mainly when it comes to the comments and endorsements that people make, in order to be able to extract this information and understand what is the right match to make. If you have any other methodologies to tell us in the future, I will drop down my Discord, and then we can meet one-to-one and we can discuss about other algorithms to open up our eyes on different ways that we can use all this data. Thank you.
Thank you, Miltos. So yeah, I'm super excited. Like, the best thing about having grants is that we can use all of these tools in the Algovera community, hopefully in future as well. So yeah, I'm super excited about that. Okay, cool. So next up we have Algorand ML prediction oracle.
Hi, I hope you can hear me, because I've never practiced the presentation of like AppGather.
No problem. I'd say it's a lot of people's first time.
Can you see the screen?
Yeah. Loading
okay.
now.
Sorry, like I'm a bit anxious, but the project is is a sort of an extension of the project that we've just submitted, like on like a hackathon sort of thing. But
sorry to interrupt, but your screen is black at the moment.
It's black.
Should we be seeing something?
I mean, it's not good, right? It's black. Yeah, it's just unfortunate, I guess, but I'll try to show.
Oh yeah, now we're good. Yeah.
Yeah, I mean, yeah. So like the project is an extension of like a hackathon project, basically, and just like months of working with smart contracts on Algorand, which has a pretty unique like EVM, not EVM, but like virtual machine. And I think like the idea behind the project is that like the crypto assets are greatly correlated, and basically all the cryptos are just moving in tandem, right? There's like significant amount of research that shows exactly that. There's like also significant crypto volatility, and we think that like automated prediction market maker would provide basically a diversification for in Web3 space, and we could also I guess inspect the information and just gather more data, just due to the nature of like how indexers in Web3 work. So essentially, like we built this demo where you could like where you set up the AMM, and like you fund the AMM and then swap, and once the event is actually resolved, you could actually like redeem the tokens. And we had a plan of adding multiple pools, implementing more options, and implementing efficient Oracle. which would basically assist on gathering the data for our users and just seeing, I guess I'm just like really interested in patterns in the data in Web3, just like generally. And like the inspiration behind the project is basically like the Poly market. It's the only alternative right now, which is available on Polygon. And it allows you to bet on your beliefs, I guess. So for example, Ethereum merge, right? When will it happen? So like basically based on the insights, it will happen before probably September. And yeah, so yeah, the code is also open source, and we implemented the smart contracts in Python. And I think we've also made an article that gathered the data and just estimated the volume on transactions, and like the difficulties on, for example, gathering the data from SDK indexers are pretty significant. There are like plenty of bugs there. So yeah, it would take like plenty of time to just even gather the data correctly. So yeah.
That's awesome. Thanks for the presentation. I was just picturing that we might have some prediction markets for the next round of Algovera grants. I think that would be super cool. Everyone can bet on who the winners will be. Does anyone have any questions?
I came in late, so this essentially is a market prediction aggregator over any type of like prediction, essentially market. Is that?
I think like the key idea was just building a smart contract that would allow like users to spawn like this, basically like just copy the code, deploy the contract, and then implement like anything they want on like the front end basically, and estimate like build their own rules, for example, and just spawn, for example, like similar markets to Poly market, basically. Yeah.
Can you send a link to GitHub again in the chat?
Yeah, sure.
And I think you have a blog post in your proposal as well, right? For people who are interested in more information.
Yeah, definitely. Yeah.
Awesome. Okay, great. So next up, we have defining means to a Web3 project. I think MetaMyth, this is you, right? MetaMyth?
Can the previous person also stop sharing?
And maybe we'll come back to MetaMyth at the end. Mm-hmm. So quantifying trust for prescribing drugs.
That's also the same person.
Oh, yes, you're right. Okay, they can do both at the end. Cool, so capturing chaos. Charlie. I can't hear you. Can anyone else?
We're both. Charlie and I are both.
Say again?
Charlie and I are both presenting.
Oh, cool. Awesome. And PFED Prague, can you stop sharing the screen? Can we take back?
Oh, sorry. Oh, here we go. Hello? Can you hear me?
Hey, Charlie.
Oh, awesome. Now you can. I know MetaMyth said he couldn't hear you, Richard, and there were some issues with that. So if we need to wait for him or something, or maybe.
Hey, can you hear me?
I can hear you now. Cool. Go ahead.
Oh.
I think I lost him. Is it just me?
Yeah, I think it says connection is unstable.
Let's see.
Is there an issue there?
Yeah, maybe we'll go ahead with Charlie again.
Okay. Yeah, just let me know. Alrighty, so I'm gonna share my screen. Now, am I able to share it while he's sharing his screen, or how is that gonna work?
Yeah, give it a shot.
Okay, hopefully you guys can see this. Okay, you guys see yourself? Okay. Can you guys see this?
Yes.
Okay, yep. Awesome. Alrighty then. All right, so we are capturing chaos. So here's just a quick overview of our squad. Today it's just going to be myself and John presenting today. We have a few graduates helping with this project, but mainly Kyle Hayes is going to be the main guy with that. We also have a research professor who is a professor at our university here in the United States. And so, yeah, that is our squad. Josh, I'll take it over to you.
Yeah. So just to give you a gist of our method, it's a stochastic approach to numerical modeling, meaning that it yields multiple solutions. And so recently we've done a comparison with 4 other machine learning techniques, and we've proven to be faster and more accurate. So this has motivated us to tackle the chaos problem in the context of the Lorenz 1996 model. So ideally, our probabilistic model would be able to account for the variability that arises in chaos.
So some examples of chaotic systems in the real world are weather forecasting, computational fluid dynamics, and chemical reaction networks. In 2021 alone, there was around $150 billion in damages caused by weather. And weather, just like all these other ones we're about to talk about, have a very huge emphasis on accuracy, and weather specifically has a huge emphasis on time. Computational fluid dynamics can be applied to anything, right? As there's a picture there, it can model the aerodynamics of your car, as well as it can demonstrate the heat transfer between pipes. Chemical reaction networks are in that lower right, and basically they are models that try to model how chemical reactions work in nature. So BSS ANOVA. Our GP utilizes a KL expansion, more specifically a decompressed kernel BSS ANOVA. Unlike other GPs, our GP operates on an O of NP basis and an OP per point of inference, where N is the size of the data and P is the number of terms produced from the KL matrix. So that basically means that we're able to operate not dependent as much on the size of the data, where a lot of GPs usually get bogged down in time. So we're able to run fast and accurate computations. Another thing that helps is with some of our other optimizers and other methods that we use, like some thermo, spin, flip, Monte Carlo algorithms, we're able to derive dynamic problems and turn them into static problems.
So the problem of the 1996 model was developed by a guy named Edward Lorenz, who is dubbed the father of chaos theory. So his model is, it conceptually resembles weather phenomena and other chaotic systems because it's so unpredictable. And so by applying our approach, we hope to lay some groundwork for further development, which will allow us to create tools to better model chaotic systems. And so in our testing, we compared a benchmark of a dynamic system. And at the top here, you can see a static derivative estimation. And so we've compared against random forest and recurrent neural nets. And we have overall a lower mean absolute error. On the bottom, you can see some of our dynamic predictions, which were against the long short-term memory and the gated recurrent unit neural nets. And overall, we also have a lower mean absolute percentage error, as well as it took a fifth of the time to complete the computation. So some of the deliverables that we'll be looking at from this project is a high resolution Lorenz 96 datasets, which we will be producing using the HPC is available here at West Virginia University. And that is something that we could share openly on Ocean or with Algovera, just for other ML groups. And we'll also have the model of the Lorenz 96.
Awesome. Could I talk about the future work for like 20 seconds?
Yeah, you can use the time for the questions to finish off the presentation if you
Awesome.
want to do that.
Yeah, this is the last slide. So just to quickly on the future work, as Josh said, we really do want to involve the community more, and we're going to publish our methods and everything that has to do with that. This is definitely because of the application and how many industries can benefit from the accuracy that our methods provide. We definitely want to reach out to other companies. I put a few here. That would definitely benefit from the accuracy and time and less computing required for these types of problems. And that's it.
Cool.
That's
Any
awesome.
questions? Oh gosh, it's a matrix right now.
Chaos.
Literally. And thank you guys so much.
This one is close to my heart. My background's in fluid dynamics, so it's good to see ML applied to fluid dynamics, and great to see people not using deep learning too.
Yeah, I mean, that biggest thing with that is Josh and I, and pretty much everyone, the area that we focus in is mechanical and aerospace engineering. So machine learning is definitely new to all of us. And that's why we really wanted to partner with Algovera, is that we don't have, like, I'm gonna be honest, I got a crypto wallet for the first time to get the community badge, right? So all of this is very new to me, and it's definitely stuff that I want to learn. And I think having us be a part of Algovera and honestly learning more about Web3 and the applications that it can provide is a really cool thing, and I want to continue to be a part of the community.
That's great to hear. Great to hear. That's what we're here for. So any help you need on the Web3 sides, let us know. And also anything on deep learning sides. I'm a mechanical engineer. I've come through the same journey as you. So hopefully I can help you out.
100%. Thank you. Thank you so much. And thank you guys.
We can move on to the next one, Richard.
Okay, awesome. So next up is Blur.
Hey, can I share my screen? Just a second.
Please do.
I hope you're able to see it. All right. So here's the project.
Sorry, this is MetaMask.
It's defining means to a Web3 project. Since the outburst of Web3 into the mainstream, it has been a one-way road where people are just onboarding and there's no retention at the gate level or any other level. So what I'm trying to establish with this project is some sort of baselines in which people can collaborate on certain projects, form groups, and how particular subgroups. Okay, sure, sorry. So what I'm trying to focus on is allowing people to retain on Web3 by forming some sort of groups, and stability between those groups will be analyzed very soon as well. All right, so what's the base principle that I'm using? It's based upon a paper that I co-wrote with the Active Inference Lab and OpenScientia. So shout out to both the labs doing awesome work in cognitive neuroscience space. So forming teams, that's the base question of the whole project. And how do we interact between different teams? All right. It has to be based upon some sort of ground level phenomenon that has been occurring, and free energy and active inference does seem like one where it's very well proven in neuroscience and cognitive sciences literature. All right. What we need to find first is a requirement distribution on a project and an individual's preference distribution. So what we'll likely obtain is probability of a person and a given skill set jointly through a collaborative index. So it's denoted mathematically through this joint equation, joint probability distribution equation. And one of the pitfalls for this is it's not computationally tractable. So we need to do some sort of neat mathematical tricks just to calculate these things. Now, how do we do that? If you look at the prior equation, multiply this thing just by Q of S, that is probability of some other state in different form, and take a negative log of it. Then there's something called a Jensen's identity, which just describes minus ln x being less than minus of ln x. So that's how you create some sort of lower bound into the system. And now the problem just becomes optimizing over the different parameters and ultimately minimizing the free energy. And this is how a group can be formed into the DAO. Now looking into how subgroups will interact with each other and how will this free energy come into the fray once again. So it's some sort of algorithm that I wrote a while back, working on this particular project. It mostly dealt with stability permutations over subgroups. So you have people with asymmetrically distributed
Did we lose him?
that we saw on the first slide, and we can continue over that. So that's how I'm looking to end this particular presentation on finding groups with projects and then stabilizing the whole subgroups present in the DAO through the free energy principle. Okay.
Awesome, bang on time. I'm not sure if MetaMyth can hear me. It seems not.
Any questions?
I have a question.
Yeah, sure.
So the math you presented is a bit above my pay grade, but I do want to ask, like, what, since we're dealing with groups of people, what exactly is the behavior that you're quantifying over? And how does that, the result will be, how would you make people behave the way your model predicts they should to maintain the group?
Sure. What happens is it's not a totally out of the world thing that I'm presenting here. It's more of a group stability thing that I'm trying to figure out. First of all, it's a stability between individual and the requirements in the project. So we're looking for an overlap between these things. It's an embedded projection of people's skill set over the required distribution. Now you'll have some sort of intersection between the distributions, and that particularly is something that is encapsulated by this equation. That is a summation over the probability states. And if you have studied a high school math a bit, summation or continuous summation often leads to integrations and sigmas and things like that. So that's where the intuition comes from. And yeah, I hope I answered your question.
Yes, so it's more of a prediction for the leadership of the DAO to understand if it's going the right direction. Am I understand this right?
Yeah, probably. But it's not just a leadership thing. It's more into how well a person matches with the requirement distribution of the project. And then when you have formed those groups of the project groups, how do those subgroups interact between each other? And that's encapsulated in this algorithm where you have symmetrical groups with people with similar skill sets, all the way to a symmetrical group where you have unlike any symmetry in the system.
Interesting. So it can be even integrated as a add-on or a tool for DAOs, and that you can like upgrade the data.
Yeah, exactly. That's what it was meant to be in the first place. A toolkit for a DAO.
Awesome. Kind of like an alternative approach to Eden as well, which uses graph convolutional networks. This is using a different type of intelligence theory called active inference. So I'm super excited by this. I think MetaMyth has another presentation. I don't know if you can hear me. Maybe someone else can. Oh, you can? You can hear me now. Cool.
Yeah, finally I can hear you.
Awesome.
All
okay,
right.
So, please, yeah.
Okay. All right. Thank you, Richard. So what happened was I wanted to submit just one proposal, but I was too excited for all of them. So decided to just shift it to the community and wait for the feedback. So here's a second project, quantifying trust for prescribing drugs. The previous project was purely a theory-based implementation. This is probably a reverse into that direction. Current state of healthcare, it's very dire. We have illegible prescriptions. Patients don't know what drugs they're taking in. There's no common validation practice between diagnosis and drugs, how they are diagnosed, and it's completely a black box between everybody who's into medicine. So it's probably the pharma companies who are having most of the fun these days. It's neither the patient or not the doctor. And I want to change that, bring some sort of, not some sort of, a full transparency on how drugs and diagnoses are prescribed in India. All right, here's the abstract model of the whole medical ecosystem that we are building right here. So you have an inference AI engine which recommends certain things. If you type in things like fever, it will show you the correlated symptoms to fever. If you type in fever, it will show you what sort of diagnosis you might have and things along that line. So it's a nudging engine that I use right here to check whether prescriptions are legit or not. So what happens is a legit doctor who's validated comes into the platform, starts writing prescriptions, and those prescriptions get stored back in the backend on a graphical network, and weights between those nodes in the graphical networks are tuned on new prescription entries by the doctors. So there's where the consensus and trust mechanism validation comes in. It's mostly realignment and readjustment of weights between two different nodes. So if a doctor has written fever and prescribed a tablet named Crocin, and the other doctor who also diagnoses fever but does not think that's right, through he can totally interact with the UI and show that it's not right according to him, and that will be a devalidation in the sense to the whole thing. And that's how a shared latent model of knowledge commons will be constructed through the metagraphs and everything, and however the prescriptions are being written. Next, so it's one of the sample nodes I have already in the system. It's based on a Neo4j implementation similar to Project Eden, but here it's mostly a weighted connection between every node. So the blue ones are the drugs that have been prescribed over the diagnosis in pink, and orange is a symptom of a particular prescription. So a clustered prescription is the one you see here. It's one prescription, this is another prescription, and this is a third prescription. So it's common to find link between two different prescriptions and how they'll be validated through in real time. So since medicine being so technical and so niche, I wanted the validation system to work perfectly right, and for that we have collaborated with Paper Plane's Clinic app, which has over 1,000 verified doctors who are practicing in real-time medicine. Just a second, I'll wrap up. And that way the shared weights get updated every time a doctor writes a prescription. So here's the whole process. The doctor writes a digital RX. Those notes are stored in the backend through Neo4j. And whenever a next doctor writes similar prescriptions to it, the weights will be adjusted globally, and it's a community-owned validation engine that continues in community box. Thank you. Ready to take questions.
Awesome. I'm super excited about healthcare applications. So yeah, I'd love to hear. Maybe we have time for one quick question.
Yeah, there's 40 seconds left.
Yeah, if you guys are not asking me a question, I'll show you a bit of a demo of what I'm trying to build. Probably just take just a second. Yeah. All right. So every time I enter, so the suggestions that you see here are right off the graph that's being stored in the backend. All the suggestions that you see here, the drug suggestions and everything. So they're being validated through the community, but it's more of a project in beta right now. I'm trying to foster more doctors into the system, get more validations, get more legit prescriptions, and probably increase the legitimacy a bit more of the whole algorithm that I'm building.
Nice. It's great to see a demo. Cool. Yeah. Anyone who's interested can reach out afterwards as well. We can connect you with MetaMyth. Okay. Next up in the list, we have Blur, and I'm not sure if Wade is here.
Wade communicate, probably he move to the next project.
Okay, cool. So next up, we have NFT recommendation system. I'm not sure. Did I see Giovanni here? Don't think he's here. I was just chatting to him earlier. I think he said he might not make it. Let's see if he shows up at the end. So next up, we have Compass Labs. So I see Elizabeth and Rohan. Yeah, please, you're up next.
Can you hear me?
Yes.
Okay, perfect. Let me share my screen. We have a little presentation. Wait, Rohan, can you share? I can't share my screen for some.
Oh, I don't have the presentation. I think you just click the share screen button.
Yeah, I do.
We can just do it without the presentation, to be fair.
Give me a second. Sorry about this.
Or we can put you up next after. Will we go someone else?
Well, let's. I think if I do my entire screen, you can probably see it. Can you see it now? No.
I don't think so.
Oh yeah, here we go. Can you see it?
We can see it, yeah.
Yes, awesome.
Okay, perfect. So, let me see. Okay, so sorry. My name is Elizabeth. Nice to be here again. We also participated in round 3 with Compass Labs, so we're really happy to join again. So we're building Compass Labs. We basically want to bring the benefits of AI and advanced optimization to the DeFi space. And as a first product, we start with building algorithms to deliver active or dynamic liquidity provisioning tools for decentralized exchanges. So one thing we saw is that right now, it's not a slideshow. Let me see, let's say it like this. Okay, so right now, providing liquidity is really complex for investors, and people are not really able to quantify the risk, and therefore liquidity provisioning is really concentrated to just a few actors, and that makes decentralized exchanges actually quite prone to censorship and manipulation, but also very sensitive to market crashes if these few parties take out their money suddenly. So yeah, as I said, over 50% of liquidity providers on Uniswap V3, for example, are actually suffering negative returns. So what we want to do is build a one-click solution for this by building dynamic liquidity provisioning tools for decentralized exchanges. So we'll do this via an end-to-end reinforcement learning system that basically performs actions and adjusts all the parameters required for providing liquidity by itself. And it's optimizing for risk-adjusted returns. So Rohan should be here.
Also, I just want to say, like, I know it's not a slideshow, but I think it's fine. I'll just quickly explain the technical side. What have we done so far? Well, in the time between the last one and now, we have developed our kind of proof of concept. So we have a kind of volatility engine using a kind of cutting edge statistical model that is able to predict next day volatilities of any kind of cryptocurrency asset, basically, with respect to the dollar price. So all of this is using kind of Bayesian methods. So we're not working with numbers here, we're working with distributions. Another thing we've done is that we've developed a simulation running a trading simulation basically with our kind of reinforcement learning agent and showing that kind of outcompetes some more passive strategies, which are what you tend to see when people provide liquidity. In terms of kind of next steps, we want to develop this into a fully fledged MVP basically. So effectively, the goal is we want to show backtested results of our strategy versus some more passive strategies like kind of the uniform liquidity strategy. And so, the way we're going to do this is by developing our software further into a kind of proprietary simulation software, effectively, to run experiments across kind of any decentralized exchange you can think of. So right now we've got it set up for Balancer, but we'll need to. But it's flexible enough so that it can work for any kind of decentralized exchange. And then on top of that, we kind of, once we've done that, we want to build out on-chain vaults and then finally make the front end and kind of deploy it into our own production level product. That's pretty much it.
Yeah, so in order to do that, we're trying to work with decentralized exchanges right now, mainly with Balancer. That's our biggest aim now, and also I think that's the alarm, right? But anyway, this is our team. We're 4 people now working on this, and we're really happy. We just raised our pre-seed round, and we're also happy with being part of the Algovera community. It's been really great so far.
Thank you very much, Elizabeth and Rohan. It's great to see your progress in just 1 month. So hopefully that can continue. I'm sure it will. Does anyone have any questions for Compass Labs?
Yeah, I just have a quick question, just a quick technical question. Now, when you're doing predictions, what kind of methods are you using? Like neural networks, or what are the?
So right now, not neural networks, because they are kind of. It's best to use linear approximations first, and then kind of move into the nonlinear space. So for now, it's mainly linear models where we're trying to where we sample the parameters of those linear models in a Bayesian way, basically.
All right, cool. Yeah, that's actually pretty similar to what we're doing as well. So that's why I just was wondering, because I heard you say Bayesian, and I was like, oh, I know what you're talking about. Yeah, it's really cool.
That's the main word. So that's
that's the main part of the word. Yeah, I love it. Thank you.
No worries.
Yeah, I'm not sure if you mentioned it in your presentation, Charlie, but I know you said fluid dynamics, computational fluid dynamics, but obviously the financial markets are also chaotic systems. So It's cool to see the overlap there.
Yeah, 100%. It's very similar. And that's why the Lorenz problem just has a huge application. And like I said, as soon as you said Bayesian, I was like, I bet you he's doing something similar to what we're doing. So that's really cool to see.
Yeah, we're expanding on this particular model called the stochastic volatility model, because with market, well, with at least FX returns, it's kind of stationary in the mean, but kind of non-stationary in higher moments. So especially in the second moments, like variance, basically. So yeah, it's good to create like a stochastic volatility model around that, where you represent that variance as like a distribution kind of sample using MC and stuff.
Was it you or Richard who was working on fluid dynamics before? Because Peter, the guy in our team, also did computational methods for fluid dynamics in his PhD.
I think both me and Charlie.
Yeah. Okay.
And NASA as well, right? So
Nice.
Good to represent. Cool. All right. Thank you very much for the presentation. So next up, we have Barefoot and Decentralized AI Ownership, a model for safer AI.
Yeah, thanks, Richard. I'll just try and share my screen. Is that coming through okay?
Yeah, we can see it.
Yeah, awesome. So yeah, this is a more of a research proposal. So no demos or algorithms, unfortunately, but hopefully it's still of some interest. So yeah, what I want to do is essentially kick off some research on decentralization and AI safety and how the two affect each other. This is a really understudied area, but also an area that I think is really important, sort of worth paying attention to. So a quick sort of top up on AI safety, I guess, starting with narrow AI. So many people, they compare exaggerated news stories that they see online about killer AI, the terrible Netflix recommendations at home, and contrasting those two things, you sort of tend to just dismiss stories of dangerous or powerful AI as just more sort of just news, just attention-grabbing news headlines. But I'm sure everyone here has heard that it's not all sort of sunshine and daisies. Although the AI models we have today are pretty narrowly focused, they still do cause issues. So many training data sets are biased. Models like GPT-3 and DALL-E 2 can already create extremely convincing fake content. And advances in game-playing AIs are being used in warfare. And that's just today's models. In the future, as AI models become more intelligent and more general, a whole host of new issues potentially be introduced. So over the past few years, AI experts have consistently underestimated how quickly models are progressing, and now think that we could be within decades of human-level intelligence. But why wouldn't AI stop progressing at human-level intelligence? After all, it would obviously achieve its goals with more intelligence, and it isn't limited by the speed of biological evolution. So once we're dealing with such systems, how do we align them with human values? Especially when we find it hard to quantify them ourselves. And why would it even bother listening? After all, do we really care about the opinion or the values of a chimpanzee or an ant? So to cut a long story short, AI safety is a significantly growing concern that poses real risk today, as well as long-term existential risks. And even if you think all this is a really low probability, all this talk of general AI and super intelligence, there is still really high potential damage if it does happen. And when you combine those two things, it's apparent that it is an issue that we shouldn't neglect. So how does decentralization fit into all of this? Well, the first way is pretty straightforward, and it's that we, Algovera, as a decentralized community, are AI builders, and this means we need to be accountable for what we build and how it's being used. So news of AI's wrongdoing is all over the news now, and for this reason, all the big tech giants have got AI safety teams and AI policy teams. And I think decentralized communities should too. But really what's interesting is the reverse. So how does decentralization affect AI safety? The first, I think, relates to how decentralization can incentivize the collection and annotation of more diverse data. We know that this is a big problem in AI today, and there are plenty of examples already of proposals within the community of how we can collect better data and incentivize that through NFTs and tokens and all sorts of things. But even if a model is trained on good, diverse data, it's also important to think about what we then use it for. And this is also an area where I think decentralization can play a big role. So one large concern in the AI community is a single company or group building, super intelligent or really powerful AI, and then getting to decide what it does. And now, of course, to us familiar with blockchain, we automatically think of decentralization as a good solution to this. But despite that seeming obvious, there's very little academic research on it. But it's also not that obvious that when we should or shouldn't rely on decentralization. Taking this very grant process, for example, the community is not deciding where all the funds go. That the team is also allocating some of those, and so that don't think there's anything obviously wrong with that either. It's hard to balance those two decision-making processes, and it's even harder when you're talking about what to do with a powerful AI model. So through this project, I hope that Algovera can really lead the charge on this field and hopefully end up with some real-world experiments as well. So what I want to do is create this theoretical sort of structured base of understanding, and then go on to design an experiment that could be run to really test decentralization versus centralization as models of AI control, and try and capture sort of which one is safer. So in summary, I think there's the relationship between decentralization and AI safety goes both ways. It's really understudied. I think it's a really high priority area. And ultimately, if we can do some research and do some work in here and hopefully run some experiments, it'll really also draw attention to the world of decentralized AI and hopefully pull resources in, because this topic of AI safety is growing really rapidly in the broader AI community. So thanks. And some questions from me to you. I'm happy for people to message me with answers to these, but otherwise happy to take questions as well.
That's awesome, Barefoot. Thanks a million. A lot of what you touched on is like the reason I ended up here in Web3 in the first place was issues I saw with centralized AI. And so, like you said, it's so unexplored, this area. I'd love to really push the boundaries in this direction. So I'm super passionate about your project. And I also loved the memes, top marks for memes. They were fantastic. Cool. All right. Does anyone have any questions for Barefoot? I know it must be late for you, Barefoot. I was just thinking we must let you go first next time.
No, it's so good. No.
Okay, cool. Does anyone have any questions? I think it was a super clear presentation anyway, so.
Thanks. Well, again, if these questions on the slide are questions from me to anyone here. So if you've got sort of suggestions or bits of research you've seen that you think are relevant, please shoot them over on Discord or wherever.
And on that note, we're also, at the top machine learning conference in Europe, there's a workshop for Web3 and decentralization. Maybe too late this time, but what we're starting to see is these workshops happening in the top ML conferences. So hopefully that's something that we can contribute to in the long run.
Yeah, awesome.
Okay, awesome. I think I saw the next four were like not. We were not 100% sure that they were going to be here, but I think I saw Antaraxia here. I don't know if you want to present Alsats.
Sure. It's nice to be here.
Welcome.
All right, so let me just share my screen. All right. Okay, so very happy to be here. I think I've interacted with you guys on Discord, several of you, and it's happy to finally talk to you. So let me just present Alsats very quickly. Alsat stands for Active Learning for a Few Sats. Quick outline of my presentation. I'll try to motivate why Alsats is needed, how it works, and what the roadmap for Alsats is. And as the popular book title goes, you always start with the why, right? So perceptions of what it seems like from the outside in terms of industry data science task distribution. The perception is that it's all machine learning, and you couldn't be further from the truth actually. What it really is data gathering and cleaning, data labeling, huge component, development and ML ops, and some machine learning if you can get to it. And so I mean, broadly speaking, data gathering, data cleaning, and data labeling are really, really expensive. And just to understand why labeling specifically is so expensive, unlike a lot of the open source data that you have, most businesses are proprietary, and the data that they deal with is proprietary. And consequently, the labeling process is not something that you can easily outsource to something like Mechanical Turk, unless it's fairly generic, right? And so the consequence of that is that labeling is often done in-house by data scientists, because they're the people who know the data best. And so a lot of data scientists' time gets used up in this process, and data scientist time is not cheap, right? And so that's one reason. The second reason, which is linked, is that machine learning models can be extremely data hungry. The more data you feed, especially neural network models, the better they perform typically, if you're doing it well. And underlying that is really the assumption that all data is equally valuable. That's not really true, and that's what Alsats really tries to attack. And so the current flow is that you first gather all of your data, you label all of your data, you train all of your data, and then you evaluate it. And what you really need from an expense perspective is that you gather some of the data intelligently, or rather you gather all of the data, but you label some of the data intelligently. And you have this loop where you can label and train iteratively, so that you don't end up labeling all of your data, and your net expense is reduced, right? And so active learning is one way in which this problem is overcome. It's used all over the industry, and so broadly speaking, you have all of your data, your candidate pool. You fetch a new label candidate initially. You fetch that candidate randomly. You perform labeling. You train the model. Use the trained model to compute uncertainty measures for everything else in the candidate pool, and then you, based on your uncertainty measure, you pick the next most favorable candidate from the candidate pool, and you continue this loop until you're sort of satisfied with the accuracy of your model, right? The advantage of this method, obviously, is that it's iterative training, and you do guided labeling, and so you need fewer samples for a given target accuracy. Obviously, there's lots of products in the market for this, and none of those products are free. Obviously, there's a variety of pricing mechanisms. There's Label Studio, there's AcuiQ, there's SageMaker that does active learning. And on the other end of the spectrum, you have completely open source products like Modal, which is completely open source and has no support. So what Alsats, what I had in mind for Alsats was, to be more towards the right-hand side of the spectrum, so more open source-ish, but try and provide some support for this. For data scientists when it comes to labeling, and yeah. So where exactly does Alsats sit, right? So this is Alsats' value proposition. The proposition is that there's no upfront purchase that's required. No ongoing subscription. You can train and label as less as one data point. You have completely API-based training. There's no remote data storage, so you can be assured that there is no sort of funny business going on there. There's no login or password because of the fact that we're using the Lightning Network. Payment is the same as authorization, right? And everything that Alsats is able to do is because of its integration with the Lightning Network. And so I think I'm a little beyond time, but just quickly describing the Alsats architecture. It's based on Lightning with a BTC backend. So these are Alice, Bob, and Carol are Lightning clients that are connected to each other. Alice is where the server is hosted. Bob and Carol are data scientists that open channels to Alice and remit payments to Alice, and in exchange for compute, right? And I don't think I'll go through all of this because I think I'm out of time. But I just want to talk a little bit about Alsats dev roadmap. As of now, there's a demo version that's deployed on GitHub. Everything works, the API endpoints work. So the first step for me is really to deploy this on EC2 and make it a genuine sort of usable framework for data scientists. And then the next step is to try and attract data scientists to actually make use of Alsats. And so the intention really is to make this a data scientist friendly product And so the dev roadmap is really contingent on data scientist interest and feedback. And so, so there's a lot of potential things that can be done, but I want to take it stepwise. And so in this proposal, my deliverables are basically deploying this and then creating a demo app for data scientists to label their data, right? The proposal, if it is funded, then all of the funds go towards deployment essentially, as of now. So yeah, I mean, if you're interested, if you'd like to follow along, shoot me a message on Discord, or there's a lot of resources here. The presentation is available, so you can please check out Alsats and return to me with questions. That's all I have. Thank you.
Thank you very much. It's awesome. Yeah, like it's shocking to me the lack of tools around active learning, especially open source ones. That seems crazy. And active learning is an area of like crypto and Web3 that I'm really excited by, just based on like micropayments, giving ownership of the labeled data, like crowdsourcing in general. I think is a really exciting area. And we also have a few projects in this area, like DAO from round one is around like they don't use the Lightning Network, but they're using like smart contracts and stuff. So yeah, it's really cool to see our research increasing around this area, and I'm really excited about this project. I think we probably don't have times for questions on this one, but drop Antorexia a message on Discord, or like reach out to the Algovera team, and we'll be happy to connect you. I think I see Oliver here. Oliver, do you want to present your project?
I am here. All right. Hi. Thanks for having me, and thanks for hosting this grant round. Super excited to see where it goes. So I'm working on something called Rep Labs, which is about reputation systems. And my interest in this whole area is around legitimacy. But I think with the internet, we have this explosion of content that we have to interact with. At the same time, the old kind of gatekeeping institutions that used to kind of determine what is trustworthy, so universities and the state, the trust in those are kind of faltering. So I'm interested in systems that kind of help us determine who we can trust and what we can trust without relying on any centralized judgment. And my current way of exploring this is by constructing reputation systems on Twitter data, by using natural language models and algorithms like PageRank. So I'm modeling conversations on Twitter within certain lists as graphs, where like nodes are users and the edges are conversations that these users are having. And then when you want to query for a certain type of reputation, you convert that into an embedding, and then you can kind of weigh this whole graph based on how relevant these conversations are for the topic at hand. So I can maybe share my screen and give a little like preview on what this looks like as of now. See. Oh, sorry, I can't do that. I have a permission problem, and I no time to fix it now. But if you're interested, I'll drop a link to a website and where you can learn more. And I think I'll leave it at that for now. One thing that's important to add, though, also is that this kind of current iteration of doing it with Twitter data is more so a decision because there's a lot of data to work with. But the long-term ambition is to also include these kind of processes in DAO contexts and other kind of general Web3 contexts. There isn't that much data to work with from now, but a lot of DAOs are experimenting with these like praise tools, Algovera included. We actually have this integration set up for the Algovera praise tool where all of these praises goes into a database and it's converted into language embeddings, and then you kind of create a graph for the interactions that is happening within DAO, similar to what Eden DAO were onto. But right now, and for this kind of grant round, I'm focusing solely on Twitter data and building a kind of reputation tool that is on top of Twitter as a Chrome extension. That whenever you sign up for it, it gets all the tweets for a certain list, or for all the lists that it is chosen, and for all the reputation types you're interested in. Runs PageRank on them by piping all these conversations through embedding models and sentiment models, and then you can kind of have a little badge on profiles that see and trustworthy due to interactions within that list. And that's it. Thank you.
Awesome. Thank you very much, Oliver. Yeah, if you use the praise system within Algovera, it runs Oliver's algorithm in the backend. It's something that we're hoping to use more as we go forwards in future. Does anyone have any questions for Oliver? Cool. And I think I see an Alex here. I wonder, is that Alex Tosi from Themistoklis?
Hello, yes.
Okay, perfect. So I think this is the last one. I know it's been a long meeting. But yeah, please, off you go.
Let me share my screen. Can you see my screen?
Yeah.
Okay, awesome. So project Themistoklis is aiming in helping the forests from wildfires, but also it wants to help the farms to make farming easier. It will be able to count crops and trees, etc., and check for diseases. So all this will be happening through drones. There is a mobile app that is under development right now that will be able to connect many drones together through the app, different commercial drones. At the later stage, the app is always connected to a server, and later it will be actually generating the flight plans for the drones. So the users will only need to set the location for the drones to go, and the plan will be generated. It is using right now YOLO version 5 for the object detection. The current model is trained for fires, and the detection is actually happening in the server through the drones. The live feed is sent directly to the server. When a fire is detected, there will be a notification sent, and also it will be drawn in a world map that users will be able to see easily. This is the core architecture of the project. The users will also be able to generate the world maps through the drones. So what they see, it will be creating a map that they will be able to share with other users or even sell them. Finally, we're creating one drone as well that will be connected directly to the server and not through the app to make it work better than the others. That's all.
Thank you, Alex. Yeah, Project Themistoklis has been with us for a few rounds now, has also graduated to Ocean Grants, so it's great to see your progress on this. Does anyone have any questions for Alex?
I'm curious about the advantages of using drones over satellites for fire detection. Could you speak to that a little bit?
Yes, I didn't mention it actually. We want to make it easier to help the fires in an early stage that aren't actually much visible from far away, because this way they will be easier to stop them. So, yeah.
What is the difference between you and other drone intelligence companies, or are you do you see yourself doing something different, or is it just that it's decentralized and open source? How do you see yourself in relation to other projects?
Both actually. Yeah, it will be open source, but we aim to create a general system that will drive a swarm of drones. So they will all be connected to a brain together and won't be each drone for itself like most commercial.
Thank you. Looks really interesting.
Awesome. So I think that is all of the projects. I know we're over an hour and a half in now. We got through a lot of projects, I think nearly all of them. So yeah, just to start wrapping up, I guess we're in the voting at the moment. So everyone should have their reputation NFTs. And I think voting goes on until the 22nd.
23rd.
So 23rd. So
23rd, 8 p.m. UTC.
Awesome. So anyone who have a try with voting, we also have some docs to help you how to vote. If you're having issues, like please reach out to me or Hitesh or one of the other Algovera team, and we'll help you sort it out. And yeah, like if you came across any projects that you found interesting or wanted to connect with, also let us know. Feel free to just reach out in the Algovera Discord. We're really keen to like promote collaboration between projects. So yeah, hopefully you found some interesting projects, learned something new, and yeah, looking forward to seeing you all in the votes and also in the Algovera Discord. Awesome.
Thanks everyone for joining.
Sweet. Thank you. Have a good weekend.
Have a great weekend. Thank you.
Bye-bye.
Yeah,
Bye.
bye.
Bye.